Right now, as you listen to this, you are probably doing something. Maybe you're on a commute. Maybe you're cooking. Maybe you're running. Whatever you are doing, I want you to know the fact that you can do it while listening to me, that audio, those words, this exact moment, just crossed the floor of the Atlantic Ocean. It touched the freezing silt. It traveled through a glass thread thinner than your thumb, and it arrived in your ear in less than a second. You just used the most fragile, most critical, and most undefended infrastructure on Earth, and you probably had no idea it existed. We talk about the cloud as if it's a celestial entity. We look at our smartphones and imagine our data floating somewhere in the stratosphere, dancing between satellites in the clean, thin air. Let me be brutally honest with you. It's a beautiful marketing gag. The cloud isn't in the sky. The cloud is actually a massive, noisy, air-conditioned warehouse full of servers located in places like Virginia or Dubai. And to get your data there, it relies on the Earth's stitch, the network of undersea cables carrying over 95% of international data traffic. Satellite internet. To put it simply, satellites carry a tiny fraction of global data. They are vital if you live in a remote cabin, but for the heavy lifting of the global economy, satellite bandwidth is a rounding error. Today, we are doing an audit of the global nervous system. We are diving to the bottom of the ocean, because in 2026, this stitch is fraying. Welcome to Curious Minds Podcast. I'm Leo from Seattle, Washington. I want you to close your eyes and picture a digital map of the world. We are going to trace the physical internet. These cables usually begin their journey in heavily fortified concrete bunkers on the coastline, known as cable landing stations. From there, they spiderweb across the ocean floor. Let's ground this in reality. When these cables sever, it isn't just an abstract data loss. Picture a fintech startup in Nairobi during a major regional cable outage. Suddenly, their payment gateways time out. Merchants can't process transactions. Day laborers don't receive their mobile money transfers. For hours, an entirely digital economy is forced to revert to cash simply because a glass thread snapped in the dark. And who owns this map? It used to be traditional telecom companies, but today the internet is no longer just infrastructure. It is privately owned terrain. Big tech firms, Google, Microsoft, Amazon, and Meta, now represent a dominant share, often over half, of all new submarine cable capacity worldwide. The same companies that store your data are now laying the physical cables that carry it. Take Meta's Project Waterworth, announced in early 2025. It is a plan to build the world's longest submarine cable system, spanning over 50,000 kilometers. And if you look at its route, it deliberately avoids geographical choke points like the Red Sea. Why? Because resilience means not putting all your glass tubes in one basket. These cables aren't just dumb pipes anymore. They are evolving into the world's largest sensors. Through a technology called distributed acoustic sensing, or DAS, engineers can measure microscopic vibrations. It's so sensitive that on land, the Viavi system can detect a single footstep above a buried cable. Now researchers are expanding this underwater, turning telecom cables into massive sensors that can detect seismic activity and marine life. But think about the absolute absurdity of this object. That same cable that is tracking the ocean's movements also carries your Instagram reel, your grandmother's video call, the algorithmic trade that just moved $40 million between banks in Singapore and Frankfurt. one glass thread, one ocean floor. Everything. But here is the reality check. If a cable can track the ocean's movements, it could theoretically track naval movements too. This has the potential to turn the ocean floor into a giant, high-definition listening post. The question is, who is listening to the listeners? We've spent the last decade worrying about digital viruses, ransomware, phishing, logic bombs. But the physical threat is far more cinematic and far more terrifying. Let's look at the Red Sea. February 18th, 2024. A cargo ship called the MV Rubimar is hit by a missile. The crew abandons ship. The vessel doesn't sink immediately. It just drifts. For weeks, a 38,000-ton ghost ship wanders the Red Sea, its massive anchor chain dragging silently across the ocean floor. On February 24th, its dragging anchor, belonging to a ship with no crew, no captain, no destination, sliced through 3 critical cables. In one movement, it severed a substantial portion of data traffic between Asia and Europe. No hacker. No code. Just an abandoned ship, gravity, and a chain. A physical cut at a choke point doesn't just mean you're streaming video buffers. When a cable dies, the cascading failure is immediate. Your salary transfer? Delayed. Hospital payment systems in London? Forced offline. Financial systems don't collapse instantly, but latency spikes. High-frequency trades fail. Millions of dollars begin to stall in a digital purgatory. A single anchor. One ship. A continent financially isolated. This isn't paranoia. It is historical precedent. We know about Cold War-era operations where nuclear submarines were specially retrofitted just to tap into undersea communication lines. Today, that espionage has simply evolved. When 2 undersea communication cables in the Baltic Sea were severed within hours of each other in late 2024, one country's defense minister publicly stated that they had to assume the damage was caused by sabotage. The gray zone of hybrid warfare isn't happening in the cloud. It's happening in the mud. We are witnessing a paradox. We are building a world heavily reliant on the cloud, designing the most sophisticated AI models the world has ever seen. But these models rely entirely on the hardware engineers, the survey ships, and the cable-laying crews who physically stitch the continents together. You can have the best AI in the world, but if the cable connecting your city to the data center is snapped by a ghost ship's anchor, your screen goes dark. So what does this look like in 2030? The nations that survive the next decade won't just be the ones with the fastest microchips. They will be the ones with the most heavily defended navies patrolling the shallow waters where these cables make landfall. Picture it. Autonomous drones moving silently along the seabed, mapping vulnerabilities. Naval vessels permanently patrolling cable landing zones. Fiber optic routes classified with the exact same level of secrecy as nuclear missile silos. We could see the absolute militarization of the ocean floor. Because in the 21st century, data is the new uranium. Which brings us back to you. The Earth's stitch is fraying. So how do we live in a world where our entire digital lives hang by a literal thread? Here is your assignment this week. I want you to build your own personal disaster recovery plan. Nothing paranoid, just practical. First, go to an ATM. Withdraw enough physical cash to buy groceries and gas for 1 week and put it in a safe place at home. If the local cable landing station goes dark, your digital wallets and credit cards are just useless pieces of plastic on a dead network. Second, check your backups. If your life is entirely in the cloud, it is entirely underwater. Buy a physical external hard drive. Back up your most critical documents and family photos locally. Third, create connection redundancy. If your home broadband gets cut, do you know how to tether your laptop to your phone's cellular hotspot? Figure it out today. The internet isn't magic. It is physical infrastructure, and infrastructure breaks. Because the next time the internet goes down, it won't feel like a glitch. It will feel like a cut. Make sure you are prepared for it. I'm Leo, and this is Curious Minds Podcast. Stay curious, stay sharp. See you next week.